onto the lesson where we look at absolute value functions, chapter 2.5a. For the warm-up, what do you think was Bed Bath Beyond's net profit last month? So where did this come about? So I actually used to work for Bed Bath Beyond. They were a retail store selling all kinds of stuff, bedding, bath, and beyond, and like toys and all that stuff. But they have since gone out of business. In July of 2023 is when they filed for bankruptcy, and now they are owned by Overstock.com. So the answer to the warm-up is that they actually made $0 profit because they don't exist anymore. They are out of business. So just messing around. But number 0 has some significance here. So in class, I had all the students guess what the net profit was. I guess I assumed no one had ever heard of Bed Bath Beyond before. They hadn't known that they shut down. But we plot each student's guess onto a graph, and then the vertical axis you see represents the absolute guessing error. In other words, how far off from the actual answer was your guess? Or in other words, how far from 0 was your guess? So you can see the points form this V shape as a result of applying them. And that's what we notice number 2. So to find the output given the input, we can basically take the guess, whatever guess you want, like this one, and we just measure its distance from the absolute answer, which was 0. So what we have here is known as the absolute value function, which basically you input a value and you measure its distance from 0. So in practice B, we play around with that idea. This is absolute value of x. These little vertical bars are absolute value symbols. So let a of x equal the absolute value of x, which gives the distance of x from 0 on the number line. So absolute value of 10 would just be 10 if you draw a number line. Here's 0, and then here's 10. They are 10 units apart. And then absolute value of negative 10, even if you have a negative value, you're still 10 units away from 0. Okay, distance is a positive quantity. So essentially, it says it here. Absolute value function is measuring a distance from 0. And distance can only be expressed with a positive value. So whether you're at positive 10 or negative 10, or some positive number or some negative number, in relation to 0, you are that many units away as a positive number. So you can fill out the table of values here with that in mind. Negative 8 becomes positive 8, negative 5.6 becomes 5.6, and hopefully you're noticing that any negative number stays the same, except now it's just a positive version of the original. Okay, these are all the same as x, except they're now positive. And then absolute value of 0 is 0, because if you're at 0, then you're 0 units away from 0. And then absolute value of any positive numbers gives you that same number back. So then we sketch the graph of a of x, and we see that reshape from the warm-up, just from applying the points. So the domain range of a of x, you can see the graph goes left forever to negative infinity, shown by the arrow. It goes to the right forever to positive infinity. That was negative infinity on the left. Are there any breaks or gaps in the graph? Anything weird happening? No, it seems to be continuous the whole way. There is a change in direction at 0, 0, the origin, but the graph it includes the origin. There's no open circle there. And this makes sense because with the absolute value of x, I mean, there's no restrictions at all on what x can be. Okay, the number line has all real numbers on it. So you can take any real number on the number line, positive or negative, and measure its distance from 0, and you won't run into any trouble with that. The range is bracket 0, comma, infinity. This makes sense because if you take the absolute value of a number, you only get positive outputs. And you could get 0 too, if x is 0. You cannot take the absolute value of something and get a negative. That's impossible. You can only get a non-negative result from taking absolute value of a number. In question 5, our friend Spiffy thinks he's cool. Spiffy tries to express a of x equals absolute value of x as a piecewise function, and he is successful in doing so. So we have to explain why Spiffy is correct. So we got a of x equals negative x if, remember this is absolute value of x, equals a of x equals negative x if x is less than or equals 0, or a of x equals x if x is greater than 0. So we could take the pure algebraic standpoint here, and looking at the graph, this downward sloping piece is just negative x. It has a slope of -1 and a y-intercept of 0. And then the upward sloping piece is positive x because it has a slope of +1 and also a y-intercept of 0. And the domain restrictions make sense because 0 is where the graph changes direction. Notice how it's negative x if x is less than or equal to 0, and then in the other inequality, it's just greater than 0. It actually doesn't matter if maybe this was just less than and now it's greater than or equal to. That's up to you. But one of them has to be included, the other must not include x equals 0, otherwise it wouldn't be a function, as if x is 0, it would be unclear which function to let x be 0 in. I also have another way of looking at this. If you look at the green part here. This piecewise function captures exactly what an absolute value function does. So again, x could be anything, positive or negative. So if x is a negative number, and you take the absolute value of a negative, you essentially multiply it by -1, and then it becomes positive. So suppose x equals -3. Okay, the piecewise function says you would do -3, because in this domain, x is -3, not in the other domain. -3 is less than or equal to 0. So -3 would give you +3. And that makes sense because the absolute value of -3 is +3, the way we know the absolute value function. And then for the second case, let's say pick a positive x value. So if x equals +3, then, well, just let this x equal 3, and you get 3. And we do know that absolute value of 3 equals 3. Now you will have to be comfortable with writing piecewise functions given a transformation of the absolute value function. So if I have the same a of x as a piecewise, but now I want to find the piecewise function for a of the quantity x plus 4, we do this as follows. So first, know that the +4 is a translation of a of x. It will make the graph move to the left by 4. So that means just take each piece, including the inequalities, and just imagine shifting them to the left by 4. And when you go to the left or to the right is an inside change. So notice how I put the negative outside the parentheses here, and then in the parentheses, I put x plus 4. Okay, it has to be done that way. If you just write -x plus 4, then this is incorrect. It actually would not be left 4, that would be up 4. You're depicting, oh, we have -x and then outside that +4. But we want we want to add 4 to the x as an inside change for it to go left by 4. And then the inequality goes from 0 to -4 because we went left in a negative direction. Then you take the other part, x, and then, I mean, you could put that in parentheses if you want. But x plus 4 is just x plus 4. There's no negative or anything else in the way of writing that expression. So no need to put parentheses, but feel free to do so. It makes you more comfortable. And then that case happens if x is greater than -4. And on Desmos, this all makes sense. So if we look at the original graph absolute value of x, we took all those points on that green graph, we move it left by 4. So now the vertex of the graph for 0, 0 becomes -4, 0. So -4 is now the turning point. In other words, the x value where something changes. So here's negative quantity x plus 4. And then here is x plus 4. And then the inequality would have to be at reference -4 as the turning point. Very similar to that, if we have a of the quantity x minus 6, we shift the graph to the right by 6 units. Again, this is an inside change, so write negative parentheses x minus 6, close parenthesis, and then the other case, just x minus 6. Okay, now we took absolute value of x, we shifted to the right by 6, so x equals 6 is now the turning point. So the first case happens if x is less than or equal to 6, and then x minus 6 occurs if x is greater than 6. And that's the lesson. Thank you for watching this video. Have a great day. Go Riders.